So next up, Professor Julien Harou.
Yes, hello. I'm pleased to speak with you today. Thanks for the organizers. So can we go back to the title slide? Right, so, okay. Okay, forget it. I don't know where my title went. That's fine. Let's go to the next slide. Oh, there it was, digital. Okay, so what we're doing here, this is funded by the Future Dams project. It's an 8 million GCRF project. And we're looking at how to design at national scale sustainable water, energy, food, environment systems. So how can we invest billions of pounds, billions of dollars into integrated infrastructure systems? So the way we do that is through three technologies. We link social and environmental and engineered system simulators, like the one that you see here, which combines a river basin and an energy system or power system simulator at national scales. We take those simulators and we connect them to search algorithms over the cloud. So these are artificial intelligence optimization algorithms. And then we identify optimized packages of interventions and see across social, environment, and engineering and service level criteria, how can we invest in the smartest and best functioning packages of interventions to provide good water, energy, food, environment systems in the future. So let's look at a case study. This next slide shows a case study of Ghana. So it's a national water, energy, food study. We're looking at meeting future energy demands, minimizing hydroecological damage from the dams, and minimizing intersectoral conflicts. So how can you prevent the different economic sectors from stepping on each other's feet? In this particular example, we're not going to allow any new dams. So we're just going to try to maximize how current dams are used. Next slide, please. Okay, so the way an engineer or an economist would see this problem is there's a few things that we want to minimize, others that we want to maximize. So we want to minimize things we don't like investment costs, operating costs. We want to minimize load curtailment. That's when you don't have any energy and you turn on the light and there's no current, no electricity. We want to minimize emissions. We want to minimize ecological negative alteration, but we want to maximize food production and maximize the ability to grow crops along riverbeds. And so the way we're going to do that is, so we simulate this entire system with our open source simulators deployed on the cloud. And we ask the computer, we just say, what are the ways to operate all the dams throughout the entire countries? How should we expand the renewable and non-renewable power mix, so solar, wind, biogas, but also conventional sources like thermal? And how should we extend the transmission lines between these to maximize all these social environmental goals? Next slide, please. Right, so let's look at three solutions. So if we can imagine three pre-packaged solutions. One thing is you could just imagine rethinking how you use all your water storage assets throughout the whole country. So that's what we did in green. In yellow, we reoperated all the dams, but we also included new transmission lines. And in the third one, we did both of those, but then we also added bioenergy expansion. So we're gonna have to go straight to the results here. Next slide is, now hopefully this is not too hard to digest. Just look at the different axes, look at how they're labeled, and imagine that, well, good is up. So if you had a perfect resource system, it would be a straight line across the top. So each of these lines represents hundreds of investments of multi-billions of pounds at national scale. And if we had a perfect line across the top, it would be a perfect system. Of course, you can see that lines are crossing, there's trade-offs. And so our three scenarios in green, yellow, and red score variably, but you can see that the red one is the one that allows to go most closest to the top. So we're able to achieve the best performance. Let's skip through the next two slides. So you can skip these two and just go straight here. This is one of these designs. So one of those lines, which was very high functioning, each one of those lines is a detailed design. So here's just one example of these optimized designs. So this is showing the energy infrastructure system and how we would reoperate the entire energy and water system at national scale. And next slide. Okay, so these are just wrap-ups. So this shows that you can rethink how countries solve water and energy and invest in water and energy at national scale. And the next two slides show how we do this in terms of software. So this is all online software. We're able to host these open source simulators online and manipulate them online with our stakeholder partners. And the last slide shows you the website where we do this. This is funded by Future Dams. The website's waterstrategy.org. And in the future, we'll have a separate website for water energy systems. This one's just for water. And so please look at the futuredams.org website or the waterstrategy.org if you'd like more information. Thank you.